Question 1. Through the lens of HVACR brazing safety, Mr. Ahmed is preparing to braze copper tubing inside a confined mechanical room with poor airflow. What is the most critical safety measure Mr. Ahmed should take before starting the brazing process? A. Use a fire extinguisher rated for electrical fires nearby. B. Ensure the area is well ventilated or use forced ventilation. C. Wear a standard dust mask for respiratory protection. D. Remove all fire alarms to avoid false activation during brazing. Answer. Correct answer. B. Explanation. Ventilation is paramount when brazing in confined spaces due to the hazardous fumes produced by flux and burning filler metals. Ensuring proper airflow or forced ventilation prevents the accumulation of toxic gases, reducing the risk of asphyxiation or inhalation injuries. Fire extinguishers for electrical fires are not the primary focus here because brazing hazards are thermal and fume-related rather electrical. A dust mask does not provide adequate protection against fumes. A respirator may be necessary if ventilation is insufficient. Removing fire alarms is dangerous and violates safety protocols, thus ensuring proper ventilation aligns with OSHA and industry safety standards. Question 2. In the context of brazing copper to steel joints in an HVACR system, which filler metal should Mr. select to ensure a strong, reliable bond without contamination? A. Copper phosphorus alloy. B. Silver-based brazing alloy. C. Lead-tin solder alloy. D. Zinc-based solder. Answer. Correct answer. C. Explanation. Copper phosphorus alloys are excellent for copper-to-copper brazing but are not suitable for steel joints due to lack of wetting and bonding. Silver-based alloys are versatile but generally preferred for copper or brass joints, not steel. Lead-tin solder alloys operate at much lower temperatures and do not provide the strength required for HVACR brazed steel joints. Zinc-based solder is not commonly used HVACR brazing and can cause brittleness. Proper filler metal choice depends on metallurgical compatibility and mechanical strength requirements. If for copper to steel, silver or specialized alloys designed for steel are ideal, but among the options, lead-tin solder is least suitable, confirming the need for silver-based brazing alloys in steel joints. Question 3. Given the circumstances that a technician observes a complete alloy flow and a visible pinholes on a recently brazed joint, what is the most probable cause of this issue? A. Excessive cleaning before brazing. B. Insufficient heat applied to the joint. C. Over-application of flux causing contamination. D. Using the wrong type of torch flame. Answer. Correct answer. D. Explanation. The wrong torch flame, such as an oxidizing flame, can cause oxidation on the metal surface, which prevents proper wetting and alloy flow, resulting in pinholes and incomplete coverage. Insufficient heat typically results in poor filler flow, but does not necessarily cause pinholes. Excessive cleaning usually improves the joint quality rather than worsening it. Over-application of flux can cause spattering, but is less likely to cause pinholes. The primary cause is surface oxidation from an incorrect flame. Thus, the flame type is critical to ensuring proper brazing joint integrity and avoiding defects. Question 4. When considering the refrigeration cycle, Mr. Dyers needs to braze a connection on the liquid line near the condenser. Why is it important to avoid overheating the tubing during brazing in this location? A. Overheating could cause refrigerant leaks due to metal expansion. B. Excess heat can degrade the refrigerant oil, affecting system lubrication. C. The tubing may become brittle and crack immediately. D. Heat will cause the condenser fins to warp permanently. Answer. Correct answer. A. Explanation. Excessive heat during brazing causes thermal expansion, which can damage the tubing or create gaps leading to refrigerant leaks. Degradation of refrigerant oil usually occurs during system operation rather than brazing, while overheating can eventually weaken tubing. Brittleness and cracking are long-term issues, not immediate effects. Warping of condenser fins is unlikely unless heat is directly applied to the fins, which are not brazed. Preventing leaks by carefully controlling heat protects system integrity and refrigerant containment. Question 5. According to recent studies in HVACR brazing practices, what is the main benefit of using silver-based filler metals compared to copper phosphorus alloys? A. Low brazing temperature. B. Superior joint strength with dissimilar metals. C. Fluxes are necessary for silver-based alloys. D. They are less expensive and more readily available. Answer. Correct answer. See explanation. Silver-based filler metals typically require flux to prevent oxidation and promote wetting. Copper phosphorus alloys are often self-fluxing on copper but not suitable for dissimilar metals. Silver-based alloys offer superior mechanical strength and versatility for joining dissimilar metals, but this comes with the need for proper flux application. Low brazing temperatures and cost advantages depend on alloy formulation. Generally, silver alloys are more expensive. Therefore, the key distinction is that copper phosphorus alloys can often be brazed without flux on copper tubing, while silver-based alloys require flux. Question 6. While examining a brazing joint, Chang notices uneven filler metal distribution and a dull, grainy surface. What should she infer about the joint quality and next steps? A. The joint likely has proper metallurgical bonding and no further action needed. B. The joint may contain porosity or contamination and requires rebrazing. C. The dull surface is normal for copper tubing and can be polished later. D. The filler metal used is incompatible with the base metals but is structurally sound. Answer. Correct answer. A. Explanation. A properly brazed joint should exhibit a smooth, shiny, and uniform filler metal surface indicating good capillary flow and bonding. A dull, grainy, or uneven surface generally signals porosity or contamination, weakening the joint and potentially causing leaks. Such joints require inspection and often rebrazing after cleaning and preparation. The dullness is not normal, and polishing does not correct metal defects. Filler metal incompatibility usually causes poor flow and joint weakness, not surface dullness alone. Thus, the observed condition suggests compromised joint quality requiring corrective action. Question 7. Based on the information about HVACR system pressures, Mr. Patel is troubleshooting a system with abnormally high low side pressure after brazing repairs. What could be the underlying cause? A. Using a filler metal with too high melting temperature. B. Incomplete evacuation of nitrogen from the system. C. Presence of moisture or non-condensable gases trapped after brazing. D. Incorrect torch flame setting during brazing. Answer. Correct answer. C. Explanation. High-low side pressure often results from moisture or air, non-condensable gases trapped inside the system, which can occur if the system is not properly evacuated after brazing. These gases increase pressure and reduce system efficiency. Filler metal melting, temperature, and torch flame settings affect joint quality but do not directly cause pressure issues inside the sealed system. Incomplete nitrogen evacuation may pressure variations but not sustained high-low side pressure. Proper evacuation and leak testing post-brazing are essential for correct system pressures. Question 8. Considering the evidence on brazing joint preparation, what is the best practice Mr. Kim should follow before brazing copper tubing to ensure optimal joint strength? A. Apply flux directly to the outside of the joint without cleaning. B. Cut tubing ends square, deburr inside edges, and thoroughly clean surfaces. C. Use a torch to preheat tubing before cleaning to remove oxidation. D. Only clean the outside surface so the inside does not affect the joint. Answer. Correct answer. B. Explanation. Proper joint preparation includes cutting tubing ends squarely to ensure full contact, deburring inside edges to prevent obstruction of filler flow, and thoroughly cleaning both inside and outside surfaces to remove dirt, oil, and oxidation. Applying flux on dirty surfaces prevents proper wetting and joint integrity. Preheating before cleaning can bake contaminants onto surfaces, making cleaning harder. Inside cleanliness is critical since filler metal flows inside the joint area via capillary action. Following these steps aligns with HVACR brazing best practices and standards. Question 9. While analyzing brazing techniques, Mr. O'Neill notices that his filler metal is not flowing into the joint despite adequate heating. What is the likely reason? A. The flame is too reducing, preventing oxidation necessary for bonding. B. The joint gap is too wide for capillary action to occur. C. Excessive flux was applied causing filler metal to repel. D. The filler metal is expired and no longer melts correctly. Answer. Correct answer. C. Explanation. Excessive flux can create a barrier that repels the filler metal, preventing it from flowing into the joint even if heating is sufficient. A reducing flame prevents oxidation and generally promotes wetting. Joint gaps that are too wide do inhibit capillary action, but the question states heating is adequate, implying preparation likely. Expired filler metals may oxidize or fail to melt properly but do not cause flow repulsion. Proper flux amount is critical for wetting and capillary action during brazing. Question 10. In light of recent developments in HVACR brazing practices, what is the most effective method for leak detection after completing a brazed joint repair on refrigerant lines? A. Using soap solution to visually identify bubbles. B. Nitrogen pressure testing combined with an electronic leak detector. C. Applying a vacuum and listening for hissing sounds. D. Visually inspecting the joint for discoloration and cracks only. Answer. Correct answer, D. Explanation. While soap solutions and vacuum listening can be helpful, the most effective and industry-accepted method is nitrogen pressure testing combined with an electronic leak detector. Nitrogen pressurizes the system without risk of combustion, while electronic detectors can sense minute refrigerant leaks with high sensitivity. Visual inspection alone cannot reliably detect leaks, especially small ones, so bubbles may not fall on all leak types or in cold environments. Thus, combining pressure testing with electronic detection provides the highest confidence in leak-free joints. Question 11. Taking into account the fundamental principles of brazing, Rivera is preparing to braze a joint between copper tubing and brass fittings. Which filler metal should he choose to ensure proper adhesion and corrosion resistance? A. Copper phosphorus alloy. B. Silver-based brazing alloy. C. Lead-tin solder. D. Zinc aluminum brazing alloy. Answer. Correct answer, D. Explanation. Copper phosphorus alloys are ideal for copper-to-copper joints but not recommended for copper-to-brass due to potential brittleness and lack of corrosion resistance. Silver-based alloys provide excellent joint strength and corrosion resistance for dissimilar metals like copper and brass, but zinc aluminum brazing alloys offer better compatibility and corrosion resistance specifically for brass fittings. Lead-tin solder lacks the strength, melting temperature needed. Zinc-based alloys form strong joints and resist galvanic corrosion, crucial in HVACR systems involving brass components. Question 12. In the modern context of brazing torch setup, Lee is tasked with adjusting the flame on an oxyacetylene torch for copper tubing brazing. What flame characteristic indicates the proper setup? A. An oxidizing flame with a long, pointed inner cone. B. A neutral flame with a clearly defined inner cone and no excess oxygen. C. A carburizing flame with a yellowish sooty appearance. D. A reducing flame with a bluish, almost invisible inner cone. Answer. Correct answer, B. Explanation. A neutral flame is ideal for brazing copper tubing. It has a defined inner cone and balanced oxygen and acetylene, preventing oxidation or carbon buildup. An oxidizing flame has excess oxygen and causes oxidation, damaging the joint. A carburizing flame has excess acetylene, producing soot and weakening the joint. A reducing flame can cause excess carbon deposition and improper heat distribution. Correct flame adjustment ensures optimal heat without contamination or joint defects. Question 13. From a practical standpoint, after completing a brazed joint repair, Simmons notices black soot deposits around the joint area. What does this indicate about his brazing technique? A. Proper flux application and heat control. B. Overheating and use of a carburizing flame. C. Adequate cleaning and joint preparation. D. Use of an oxidizing flame leading to joint oxidation. Answer. Correct answer, A. Explanation. Black soot is a sign of excessive heating and a carburizing flame excess acetylene, causing carbon deposits that can contaminate the joint and reduce strength. Proper flux application and heat control prevents soot formation. Adequate cleaning prevents contamination, but soot results from flame and heat issues, not cleaning. Oxidizing flames produce oxidation and burn marks, not soot. Recognizing soot helps technicians adjust flame and heat to optimize brazing quality. Question 14. Given the circumstances that a technician must braze copper tubing outdoors on a windy day, what precaution is most critical to ensure a successful joint? A. Use a larger flame to compensate for heat loss. B. Shield the joint area from wind using a brazing blanket or shield. C. Increase flux quantity to prevent oxidation. D. Perform the brazing at night when temperatures are cooler. Answer. Correct answer, C. Explanation. Wind rapidly cools the joint, preventing adequate heat buildup for brazing and causing oxidation. Increasing flux can protect the surface but cannot replace proper heat. Using a larger flame wastes fuel and risks overheating surrounding components. Shielding the joint with blankets or shields is a better strategy to reduce heat loss and protect the flame, but increasing flux alone is insufficient. Performing brazing night does not address wind effects and could worsen safety. Proper shielding combined with correct flux application is best. Question 15. While evaluating HVACR system pressures, Gupta finds the high side pressure abnormally low after brazing repairs. Which of the following best explains this symptom? A. Residual moisture trapped in the system. B. Presence of a partial refrigerant leak at the brazed joint. C. Incorrect filler metal causing joint weakness. D. Overheating the condenser coil during brazing. Answer. Correct answer, D. Explanation. Overheating the condenser coil during brazing can deform or damage the coil, reducing heat rejection and causing abnormally low high side pressure. Moisture usually causes high pressure due to ice or blockage. A partial refrigerant leak reduces pressure but typically affects both sides or causes a pressure drop overall. Incorrect filler metal affects joint strength but not system pressure directly. Damage to condenser alters system performance and pressures significantly. Question 16. Considering the evidence, what is the most effective method for ensuring the removal of flux residue after brazing in HVACR piping? A. Leaving the residue to evaporate naturally over time. B. Using warm water and a stiff brush immediately after brazing. C. Applying solvents specifically designed for flux removal. D. Wiping the joint surface with a dry cloth after cooling. Answer. Correct answer, A. Explanation. Leaving flux residue can cause corrosion and compromise joint longevity. The best practice involves thorough cleaning immediately after brazing with appropriate solvents or warm water and brushes, preventing corrosive action. Wiping with a dry cloth only removes loose debris but not chemically active residues. Allowing residue to evaporate is unsafe. It promotes corrosion. Solvents or water cleaning ensure flux aligning with best maintenance practices. Question 17. From the perspective of brazing joint inspection, Mr. Flores is assessing a joint and notices excessive filler metal buildup beyond the joint area. What does this indicate about his brazing process? A. Proper capillary action with ideal filler metal volume. B. Overheating and applying too much filler metal. C. Insufficient heating causing filler metal to pool. D. Correct use of flux preventing joint contamination. Answer. Correct answer, B. Explanation. Excess filler metal indicates overheating or excessive application, causing runoff beyond the joint and weakening structural integrity. Proper brazing produces smooth, even filler metal distribution confined within the joint area through capillary action. Insufficient heating causes poor flow, not buildup. Flux prevents oxidation but does not cause excessive filler. Overapplication reduces joint quality and is a common brazing error. Question 18. In response to a brazing repair on a refrigerant line, Patel must conduct a pressure test. Why is nitrogen preferred over air for this purpose? A. Nitrogen is more reactive and helps identify leaks visually. B. Air contains moisture and oxygen that can cause corrosion and combustion risks. C. Nitrogen is cheaper and more readily available than compressed air. D. Air pressure can falsely indicate a leak due to temperature changes. Answer. Correct answer, C. Explanation. Nitrogen is inert, dry, and non-combustible, minimizing corrosion inside refrigeration lines and eliminating combustion risk during brazing. Compressed air contains oxygen and moisture which can cause internal corrosion and combustion hazards, especially near open flames. While nitrogen's inertness is key, it is generally more expensive and less available than air, so answer C is incorrect. Cost is not the nitrogen is preferred. Therefore, the main benefit is nitrogen's inert, dry nature, not cost or visual leak detection. Air pressure fluctuations can occur, but are less relevant here. Question 19. When faced with repairing a leak on a brazed steel joint in a high-pressure system, Mr. Jackson contemplates whether to use solder or brazing filler metal. Which option aligns with best practices? A. Use solder because it melts at lower temperatures, reducing risk. B. Use brazing filler metal to ensure mechanical strength and leak tightness. C. Use either, as both are equally effective in steel joints. D. Use flux only to seal the leak without filler metal. Answer. Correct answer. A. Explanation. Solder melts at lower temperatures and is sometimes used for minor leak repairs on steel joints to reduce heat stress and avoid damage to surrounding components. Brazing filler metals require higher heat, which may damage sensitive areas. However, solder joints are mechanically weaker and less durable under high pressure. Using flux alone cannot seal leaks. The choice depends on system requirements, but for quick, low repairs, solder is preferred. For high pressure, full strength repairs, brazing filler metal is ideal. Question 20. In light of recent developments, what is the primary reason technicians must wear fire-resistant clothing during brazing operations? A. To prevent electrical shock hazards. B. To protect from accidental burns and molten metal splatter. C. To avoid inhaling toxic fumes during brazing. D. To comply with fashion trends in safety gear. Answer. Correct answer. D. Explanation. Fire-resistant clothing protects technicians from burns caused by heat, sparks, and molten filler metal during brazing, reducing injury risk. It does not prevent electrical shocks or respiratory hazards. These require other PPE such as gloves or respirators. Compliance with safety regulations mandates fire-resistant clothing, which is unrelated to fashion trends. Wearing proper clothing is a critical safety in brazing supported by OSHA and industry standards. Question 21. Under the assumption that HRConquer is brazing copper-to-copper joints in a rooftop HVAC unit during cold weather, which step is most critical to ensure proper filler metal flow? A. Preheating the joint to compensate for ambient temperature loss. B. Applying flux in multiple thick layers for insulation. C. Using a smaller torch tip to focus heat. D. Increasing filler metal quantity to overcome cooling. Answer. Correct answer. A. Explanation. Cold weather quickly draws heat away from the joint, preventing proper filler flow by disrupting capillary action. Preheating offsets this heat loss, ensuring the metal reaches brazing temperature evenly. Thick flux layers trap contaminants and may cause spattering. A smaller torch tip concentrates heat but can be inefficient in large assemblies exposed to wine. Adding more filler metal does not fix temperature deficiencies and may create excess buildup. Proper preheating is a recognized best practice in cold weather brazing according to HVACR industry guidelines. Question 22. In contrast to standard maintenance, is Alvarez needs to braze copper to stainless steel? What filler metal is most suitable for this dissimilar metal combination? A. Copper phosphorus alloy. B. High silver content brazing alloy. C. Lead-tin solder alloy. D. Zinc aluminum solder alloy. Answer. Correct answer. B. Explanation. High silver content brazing alloys bond effectively to both copper and stainless steel, providing corrosion resistance and strength. Copper phosphorus alloys do not wet stainless steel properly. Lead-tin solder lacks the strength and high temperature resistance for such applications. Zinc aluminum solder may bond but is less reliable for dissimilar metals in pressurized systems. Selecting high silver filler ensures strong metal bonding and service longevity, aligning with OR's brazing recommendations. Question 23. With respect to HVACR safety, Brooks is setting up his oxyacetylene torch. Which action best prevents flashbacks during brazing? A. Installing flashback arresters on both fuel and oxygen lines. B. Adjusting the regulator to maximum working pressure. C. Purging hoses with oxygen only before ignition. D. Using a carburizing flame for all brazing tasks. Answer. Correct answer. A. Explanation. Flashback arresters stop flame travel into hoses, preventing dangerous explosions. Setting regulators to maximum pressure increases risk, not safety. Purging with oxygen only can introduce hazards by displacing protective gases. A carburizing flame may cause certain is not a universal brazing setting. Industry safety standards, OSHA, NFPA, mandate flashback arresters for oxy-fuel systems as a primary protective measure. Question 24. By evaluating the brazing process, is cutter notices a joint has voids inside after cutting it open for inspection. Which factor most likely caused this defect? A. Applying filler metal too slowly. B. Overheating the joint and burning off flux prematurely. C. Using nitrogen purge during brazing. D. Allowing capillary action to fully draw filler before cooling. Answer. Correct answer. C. Explanation. Overheating can damage flux but typically causes oxidation rather than internal voids. Applying filler slowly can still work if the metal remains at proper temperature. Nitrogen purge during brazing prevents oxidation but can disrupt filler flow if pressure is too high, leading to voids. Allowing full capillary action prevents such defects. Controlled purge rates are critical to avoid turbulence inside joints. Question 25. Taking into account the role of flux in brazing copper to brass, what is its primary purpose? A. To lubricate the joint for easier filler metal application. B. To prevent oxidation and promote wetting during heating. C. To add additional strength to the finished joint. D. To seal the joint temporarily until pressure testing. Answer. Correct answer. B. Explanation. Flux chemically protects the joint surfaces from oxidation at brazing temperatures and promotes filler metal wetting. It is not a lubricant, does not add mechanical strength, and is not a sealing compound for pressure testing. Proper flux use ensures cleaner, stronger joints towards brazing best practices. Question 26. The primary reason for using a neutral flame when brazing copper lines is to A. Minimize soot formation and oxidation. B. Speed up filler metal melting by adding extra oxygen. C. Cool the joint faster for handling. D. Reduce nitrogen absorption in the copper. Answer. Correct answer. A. Explanation. A neutral flame balances oxygen and fuel, producing clean heat without oxidation or carbon deposits. Extra oxygen creates an oxidizing flame, damaging copper. Cooling joints faster risks thermal stress. Nitrogen absorption is not influenced by flame chemistry in brazing. Maintaining a neutral flame is a fundamental brazing skill taught in HVACR certification courses. Question 27. Through careful analysis of a failed brazed joint, Mr. Daniels discovers a dark, crusty residue inside the joint. Will most likely cause this: A. Using expired filler metal. B. Excessive flux burning due to prolonged heating. C. Over-tightening tubing before heating. D. Improper storage of copper tubing in cold environments. Answer. Correct answer. B. Explanation. Prolonged heating can overcook flux, leaving a burnt, crusty residue that interferes with filler bonding and can cause leaks. Expired filler metal may not melt properly but doesn't leave this residue. Over-tightening tubing affects fit but not residue formation. Storage temperature has minimal effect compared to flux degradation during brazing. Proper heat control prevents flux burnout. Question 20. Among the various methods for post-brazing leak detection, which offers the highest accuracy for small leaks? A. Soap bubble solution applied under low pressure. B. Ultrasonic leak detection. C. Pressurizing with nitrogen and using an electronic leak detector. D. Observing system pressure drop over time. Answer. Correct answer. C. Explanation. Electronic leak detectors combined with nitrogen pressure testing are the most sensitive method for pinpointing tiny leaks. Soap solution is cost-effective but less precise for very small leaks. Ultrasonic devices can help but are affected by background noise. Monitoring pressure drop is slow and non-specific. Industry best practices recommend nitrogen plus electronic detection for reliable verification. Question 29. When analyzing a brazed copper joint that failed after a few weeks, what factor is most likely responsible if the tubing shows signs of internal corrosion near the joint? A. Using copper phosphorus filler without flux in a dissimilar metal joint. B. Using too much filler metal causing turbulence. C. Cooling the joint too slowly after brazing. D. Purging with dry nitrogen during brazing. Answer. Correct answer. A. Explanation. Copper phosphorus filler can be self-fluxing on copper, but in dissimilar metal joints, the lack of flux promotes oxidation and corrosion inside the joint. Excess filler metal or cooling rates don't cause corrosion directly. Nitrogen purge reduces corrosion, not increases it. Proper filler flux selection for metal combinations is essential to prevent premature joint failure. Question 30. During the process of brazing in a tight space near electrical components is to use needs to protect adjacent wiring insulation. What is the best approach? A. Use a heat shield or fire blanket between the torch and wiring. B. Wrap the wires in aluminum foil only. C. Apply flux to the wiring to dissipate heat. D. Spray the wires with water before brazing. Answer. Correct answer. D. Explanation. Heat shields or fire blankets are the safest and most effective protection for nearby wiring and materials during brazing, preventing heat transfer and fire hazards. Aluminum foil alone reflects some heat but offers inadequate protection. Flux does not dissipate heat and is not used on non-metallic materials. Spraying water is temporary and risks introducing moisture into the work area, potentially damp components. OSHA and NFPA guidelines recommend physical barriers like fire blankets for brazing near combustible materials.